Good morning, student. So, in our previous lecture, we have already learned about what is matter, then why matter exists in three different states, classification of solid, crystalline, amorphous solid, and their properties of crystalline and amorphous solid. Then we also learn about types of crystalline solids, isomorph, polymorph, and isotropic crystalline solids. Now, in this lecture, we will see the classification of crystalline solids. Crystalline solids are classified on the basis of their type of molecules or particles, associate or aggregate. Crystalline solids are mainly classified as a molecular solid, ionic solid, metallic solid, covalent solid. Molecular solid means that is association of molecule to form a crystalline compound. Ionic solids means ions are associated in a periodically or definite order to form a solid is called as ionic solid. Metallic solid, in case of metallic solid, the reduced form of metals are associated to form a metal is called as metallic solid. For example, iron, copper, etc. Covalent solids are the molecular solids, but the molecules or atoms are covalently bonded to form a crystalline solid is called as covalent solid. Let us see one by one in detail. So first is molecular solid. In molecular solid, the crystalline solid in which the constituents, particle or molecules of same compound, that means same molecules are associated to form a solid, is called as molecular solid. On the basis of types of molecules, molecular association, the molecular solids are further classified into the polar molecular solid, non-polar molecular solid, or molecular solids having hydrogen bond. That means molecule may be polar, then may be polar molecular solids. If molecules are non-polar, then we call as non-polar molecular solid, or the molecules are polar but having a definite or specific hydrogen bonding structure in crystal form is called as hydrogen bonded molecular solid. So let us see one by one with their example. First is polar molecular solid. In case the molecular solids in which constituent particles of molecule are polar molecules of the same compound are called as polar molecular solid. Example: HCl, SO2, sulfur dioxide, etc. These are the polar molecule having dipole moment. Properties of polar molecular solid. Obviously, polar molecular solid has permanent dipole moment. So this is characteristic property of polar compound, dipole moment. Second, they are soft solid and do not conduct the electricity at solid state. Melting point of this solid are relatively low because of polarity. Next is non-polar molecular solid. The molecular solid in which constituent particles are non-polar of same compound are called as non-polar molecular solid. For example, H2, Cl2, CH4. These are non-polar molecules. These are the properties of non-polar molecular solids. These solids have zero dipole moment and held by weak dispersion forces in between them because the same molecules atoms are joint and they have zero dipole moment. Second property, these solids are soft, do not conduct electricity at solid state. Melting point of these solids are very low. Next is hydrogen bonded molecular solid. The molecular solid in which constituent particles are polar. But these molecules are held together by a hydrogen bond called as hydrogen bonded molecular solid. For example, water, H2O, NH3. These are the properties of hydrogen bonded molecules. That is, molecules are polar and held together by hydrogen bond having dipole moment. These solids are soft, do not conduct electricity at solid state. Third property, at room temperature, the solid exists in liquid and gaseous state. Now, second is ionic solid. The ionic solids are formed by the association of positively charged and small size cation and negatively charged bigger size anions. This charge on the ions, arrangement of these ions are such that they balance to each other and in the neutral form as a solid, that is NaCl, zinc sulfide, ZnS, potassium chloride, etc. We know the all ionic solids. Property of ionic solids, ions are held together by a strong electrostatic force of attraction between the oppositely charged ions. They are hard and brittle. They have higher melting points. Salts have having higher melting point but sharp melting point. Non-conductor in solid state but very good conductor in a liquid state or fused state. Next solids is the metallic crystalline solids. Metallic solids or crystalline solids are formed by the association atoms of same metallic element in reduced form. The bonding electron are delocalized over the space of the crystal and have freedom to move from one end to other end. All these bonding electron of metal atoms are like a sea of electron. The positively ions are arranged to form a canal for these electrons. The presence of this free electron make all the metals are good conductor of heat and electricity. In metallic solid, crystalline solid, the electrons are free to move from one end to another end. That's why the metals are good conductor of heat and electricity. Example, iron, magnesium, aluminum, copper, etc. The property of metallic solids are atoms of crystal are held by a metallic bond. Second, they have higher melting point and boiling point. They are very good conductor of heat and electricity because it contain these free electrons, and these positively charged make a canal for movement of these free electrons. They are malleable, lusterness and ductile properties. That's why we make the various pots, various apparatus or ornamental by using these metals. Last is covalent solid. Covalent solids are formed by a chemical bond, that is covalent bond. We know the different chemical bonds, ionic bond, covalent bonds, etc. or DT bonds. Covalent solids may be good conductor or may be insulator depending upon availability of the free electron or mobile electron. Example, allotropes of carbons are the covalent solids. Diamond, graphite, fullerene. So let us see in detail first covalent solid diamond and its property. It is polymorphic form of carbon. All carbon atoms of diamond are sp3 hybridized carbon atom. They are tetrahedral connected to form a big network of the solid. It is hardest material with very high melting point about 3550 degrees Celsius. So this is very important. The MCQ type of question may ask on this, that is, carbon atom present in diamond are dash dash hybridized carbon atom. The answer is the all carbon atoms present in diamond are sp3 hybridized carbon atom. So this is important for your MCQ type of exam or questions. So second covalent solid as a graphite. These are the properties of graphite. It is a polymorphic form of carbon. All carbon atoms of graphite are sp2 hybridized carbon atom. Similar the questions also. The all carbon atoms of graphite are sp2 hybridized carbon atom. Each sp2 carbon atom link with three other carbon atom and form a six-membered ring of the carbon atoms here. Each carbon form a three other link like that. This side, this side, and this side to form a six-member hexagonal ring. The adjacent layer of the carbon atom are held together by a weak van der Waals forces. That means this layer of the hexagonal rings, and this is second layer of the hexagonal ring, this one. Between this layer of the hexagonal rings having a weak van der Waals forces of attraction between the ring, that means maybe hydrophobic interaction. That's why graphite are the appearance of the graphite are smooth because of these weak forces between these hexagonal rings. The graphite contain free delocalized pi electron. This is very important. Graphite contain a free delocalized pi electron. Hence, it is good conductor of electricity. That's why graphite are used in the dry cells, because it is good conductor of electricity. Here, that one orbit is one pi orbit is pi electron are free, and it is delocalized. Because of this, that means carbon carbon double bond, and this is free to move, and that's why the graphite is a good conductor of heat and electricity. This is a schematic structure of this carbon ring, and these are the weak van der Waals forces between this layer of the rings in graphite. Next covalent solid is a fullerene. This is a not naturally occurring covalent solid, but it is laboratory synthesized compound fullerene, or we can say carbon. It is a third allotrope of carbon which is formed or synthesized when high power laser light was focused on carbon. The product was found to have C16, that means 16 carbon are covalently joined with each other and had a shape like saucer ball, that is हॅलो स्पेअर बॉल सारखं स्ट्रक्चर त्याचं तयार होतं 60 कार्बन ॲटमचं, आणि त्याला आपण म्हणतो फुलेरिन. द फुलेरिन इज ऑल्सो कॉल्ड ॲज बक्की बॉल. Fullerene consists of fused 5-membered and 6-membered ring to form 12 pentagonal and 20 hexagonal faces, like a football or buckyball असं स्ट्रक्चर मिळतं आपल्याला. 20 हेक्झॅगोनल फेसेस मिळतात आणि 12 पेंटॅगोनल फेसेस असतात आणि हॅलो स्फिअर असतो, त्याला आपण फुलेरिन स्ट्रक्चर म्हणतो. आणि इट इज अबाउट 16 कार्बन ॲटम 60 कार्बन ॲटम 60 कार्बन ॲटम. All the carbon atoms in fullerene are also sp2 hybridized. Right? This is important. Fullerene also, the carbon atoms are sp2 hybridized. So this is a synthetic material and having a very specific use of this fullerene. So these are the uses of fullerene. If fullerene react with a potassium to form K35 C16, that means 35 potassium molecule react with this carbon to form a compound K35C60, which is used as a superconductor of electricity at minus 255 degree Celsius or at 18 degree Kelvin. So this is superconductor because at that minus temperature, minus 255 degrees Celsius, this shows the conductivity, because at 0 degree Celsius most of compound are not shows the conductivity. But by using this fullerene, that is form a compound K35C60, which is very important compound and which shows the superconductivity, that means up to the minus 255 degrees Celsius. This may be used in this space scientists for in a space research. This material may be used in space research to form a conducting material or electrical connection with this material, and this shows the conductivity up to this minus temperature, that is minus 255 degrees Celsius. This is very important material. The question may arise that fullerene or what uses of the fullerene, that means the dash material of fullerene is formed, which is used as a superconductor, that means K35C60 material which is used as a superconductor. Fullerene react with most of transition metals and to form a catalyst. So this is maybe used as a PTC phase transfer catalysis, and most of transition metals are used as a catalyst. So fullerene also react with this metal transition metals and form a very good catalyst for the chemical reaction. Third, carbon nanotube structure of the carbon are made up from fullerene and graphite. That we already known about that carbon nanotubes for various research purpose. So this will also form by using this graphite or fullerene compounds. So here we stop the lecture. Up to this lecture we have just see the crystalline compound, classification of crystalline compound. That means up to this slide we have learned about up to the macro properties. Now we will go for the micro level. That means we will see the single crystal and up to the micro level analysis, and up to the go to the element or particle up to the atoms. So this crystal structure or at micro level analysis we will see in the next lecture. Thank you.